Hey, what's going on, everybody? All right, so once again, I'm going to go over the question of the day. And so, what I had posed, excuse me. So, what I had posed was if we had this alcohol, so ethanol, two carbon alcohol, and we wanted to go to this structure, how could we make that? And you all had some great suggestions, some great ideas. So, thanks for submitting those. So anytime you're doing a synthesis, these are just kind of tips that I mention over and over again, but to keep in mind is that what you want to look for is you want to see how many carbons you start with and how many you have in the final structure. So we can see here that we have 2 carbons here and we have 1, 2, 3, 4, okay? Now, how should we go about thinking about this? So we know that 2 of these carbons are going to be the same, and probably a safe assumption is that they're either going to be these 2 or it's going to be those 2. And the reason I say that is because we'll see that we have an N carbon here or we have an N carbon here, so more than likely it's going to be, one of those. Now, between these, what I always recommend students to do is that if you have a functional group already on a carbon, then more than likely that's going to be the same carbon. So if we look here, we've got an endpoint which matches here. We've got a carbon with an oxygen. We have another carbon with oxygen. So more than likely that's going to be the case. Now that doesn't necessarily mean that that has to be that way. There are a lot of different ways to do synthesis, but that's kind of something you want to do is count your carbons. And if you have a functional group on an atom, then more than likely, if it's in the final product as well, that those are probably going to be the same. All right, so what are some things that we could do here? So what we could do is we could take this alcohol and we could convert it to the aldehyde using PCC, okay? So we don't want to take it all, we'll see here in a minute, but we're just going to take this to the aldehyde. Now we can see here that we've got our 2 carbons, but then we need to add 2 other carbons. So we could simply take this and we could add maybe ethyl grignard. So step 1, ethyl grignard. Step 2, some sort of acid. And what that would allow us to do is give us an oxygen here, and then we would add our 2 carbons. So we can see there are our 2 carbons there, and then those are the 2 carbons we just added. And then we could see we could follow that up with some sort of oxidation. So we could say, Jones reagent, and that would allow us to oxidize that up. So the way that we could approach this is we could take this alcohol and look at it in terms of that's going to be the alcohol that we're going to use here. So we oxidize it, we can add, and then we can re-oxidize there, okay? Now, that's one way. What's another thing we could do? So what if we took this and instead we did, this time I'll write it out, so the Jones reagent, chromic acid, sulfuric acid, and what if we oxidize that all the way up to the carboxylic acid? Okay, now what could we do with this? Now this by itself, we can't really do there isn't much chemistry we can do with this. We can't add nucleophiles to this because this proton is acidic. So if we added a Grignard reagent, it would deprotonate that, and we would just wind up getting a minus charge, and then we can't really do anything. One of the reagents that you can use that if you actually want to do some sort of nucleophilic addition, as many of you may be familiar with, is lithium aluminum hydride, but that's just essentially going to take us back to the alcohol. So what could we do here? What if we took this and we did SOCl2 and we converted that into the acid chloride, okay? Or some sort of acid bromide, acid chloride, some sort of acid halide, we could convert that. Now what we could wind up doing is if we had some sort of cuprate, so let's just do ethyl to copper lithium. So some of you may be familiar with this, some of you maybe not. Let me just redraw this because sometimes it's hard to see. So this would be CH3, CH2. There'd be 2 of those, copper lithium. Let me just make sure everything's cool here. Okay, awesome. So we could oxidize all the way to carboxylic acid. We can convert that into an acid chloride. And then, like I said, some of you may or may not know this, but if you use a cuprate, so a cuprate just has a copper reagent, and you'll notice that what it'll have is it'll have 2 of, essentially in most cases, it'll have 2 of the same carbon groups. So these are both ethyls. You'll have the copper, so 2 of those attached to copper, and then you're going to have a lithium counterion, because when you have 2 of these on, this copper is going to be negative, and the lithium is going to counteract that. But it's the copper right here. And this reagent right here is nucleophilic. So the thing to think here is that acid chlorides are really, really super reactive. So if you had a Grignard to this, it would add twice. Most reagents are going to add twice because this is really, really reactive. So it's going to react once, and then you have a ketone intermediate, and then it's going to react again. What's great about the cuprates is that they'll react once. So what you can wind up doing here is just adding the ethyl group once and wind up getting this, okay? So we can go alcohol, carboxylic acid, acid chloride, and that. I think that's about the same steps. Before we did oxidation, addition. So yeah, it's going to be essentially about the same, okay? All right. So I think another one, some of you suggested, which I thought was pretty cool, is what if we started with the alcohol and we didn't think about this being our oxygen source up here, that we converted in something else. So let's say we did PBr3, and we could convert that into the bromide, okay? And then if we took that, we could use magnesium and ether, and we could convert that into the Grignard. And so that's going to be 2 carbons. And then what we're going to need here is another 2 carbon source. So what if we did an aldehyde? So formaldehyde, or sorry, not formaldehyde, acetaldehyde. Reacted with that, that would give us 1, 2. And then obviously this would be step 1. Step 2 is H3O plus. And actually, I guess I could do this. Let me keep this in the same order. So we're going to say that this is 1, 2, O, like that, just to show you that it doesn't really matter what order. But if we keep the carbons the same, so if we just kind of keep the same order, we can use these 2 carbons. That will attack something else, our acetaldehyde, get the OH. And then we can imagine doing some sort of oxidation again. And that'll give us the carbonyl, but obviously we can flip that around. If I rotate that all the way around, we can get that right there, okay? Now the reason I did this was just to show you that sometimes your professor, what I tend to do with my synthesis is just kind of keep them in the same orientation so you can see that all the carbons, we've got our endpoint here, the carbons are up, so you can kind of look at them visually and say, okay, let's overlay that. Sometimes your professor may try to flip it around to try to confuse you, to see how much you know. So that's why I wanted to do this, that you could still essentially draw your structure when your final product in completely different orientation, but it's essentially the same thing. Now I think, let's see, we did 2 different oxidations. We converted it into an alkyl halide. Trying to think if there was anything else. I think those are going to be the most straightforward ones. Trying to think if any of you all sent any other ones. I think that's going to be the basic of it. So let me just scroll through here. I tried to look up here. I don't think I saw any comments. I think just some people joining. Okay, so I don't see anything. All right, awesome. Well, that's it. Thanks so much for everybody coming on here. I'll keep this up here for 24 hours, and I'll post a little snippet on my page. Hope you all have a good one. Take care.